Our topic is computer technology. Our course code is CTE 431 week 1. So let's look at this multiplexer and demultiplexer. So a multiplexer is a circuit that accepts many inputs. In this aspect, regard to multiplexer, it is a circuit that is designed to accept multiple input and gives out one output. So let's look at the multiplexer. The multiplexer functions exactly in the reverse of a multiplexer. That means automatically it is vice versa. Since we said that multiplexer accepts multiple input and gives out one output, then the multiplexer can only accept one input and gives many output. So generally, multiplexer and demultiplexer are used together because of the communication system are bidirectional. So the word bidirectional refers to process of transmitting communication in one direction. We are still on multiplexer. Let's look at this expression. A multiplexer is a circuit used to select one of the several input signals to a signal out. So let's look at multi-position switch. Multi-position switch are widely used in many electronic circuits due to the operation of the multi-position switch is faster. So multiplexer, to be automatically selected high speed rate, they have to implement a multi-position switch on it. So that's the requirement of the multi-position switch to the multiplexer. It is recommended that it will make the circuit to be more faster. So let's look at a mechanical switch. Mechanical switch cannot perform this task satisfactorily. So we have mechanical switch and multi-position switch. Multi-position switch is more faster in terms of communication system, which allow the multiplexer to enhance the ability of the circuit. So multiplexer used to perform high-speed switching and constructed of electronic components, but with the help of multi-position switches. So multiplexer used for digital applications, also called digital multiplexer circuit with many input. It has many input, but it can only provide one output. So types of multiplexer. Here are types of multiplexer. One, we have 2-to-1 multiplexer, 4-to-1 multiplexer, 8-to-1 multiplexer, and 16-to-1 multiplexer. Regards to 2-to-1 multiplexer, we are to provide a truth table where A and B should be the two input lines. Then we should have the output, which is the Y. So we are to input 0 and 1, which is binary notation for the 2-to-1 multiplexer. If it is 4, we are to provide 0 0 1 1, then 0 1 0 1. If it is 8-to-1 multiplexer, we are to provide 0 0 0 0 into 4, 1 1 1 1 into 4. For the A side, then we are to input 0 0 0 1 1 1 0 0 0 1 1 1 into B group. So that's how the truth diagram of the multiplexer functions. So let's look at this general idea of a multiplexer within input signal M control lines and one output lines. So the M controls lines refers to the input. So let's look at the N input signals. These are the real input signals that we will be able to input into the multiplexer. We can be able to even number them, either D0, D1, D2, D3. Then the output should be Y. So the MUS is the abbreviation of the multiplexer, which is known as MUS. So this is the pin diagram of a multiplexer. So let's understand how 4-to-1 multiplexer works. So 4-to-1 multiplexer has 4 input bits, 2 control bits, and 1 output bit, as we said earlier. So the input bit can be represented as D0, D1, D2, and D3. So only one of these D1, D2, D3 can be transmitted to the output, which is Y. So let's look at the output. It depends on the value of AB, which is the control input. So the control input determines which of the input data bit is transmitted to the output, as we said earlier. So as shown in figure. So when A and B is equals to 0, 0, the upper AND gate is enabled, while all other AND gates are disabled. Therefore, data bit D0 is transmitted to the output given. So Y is equals to D0. So for the next slide, we are going to make the expression so that the explanation will be clear. 4-to-1 multiplexer. Then we now created a bracket. Then we now put 2 raised to power n times 1 multiplexer, right? So when we open the bracket, our n will be at the front. Then we will now say that n is equals to 2. That is how we got our selected line, which is the input line of the multiplexer. So let's look at the diagram to clarify us how they goes. So the two selected lines, which are known as A and B. So our input lines, which are known as D0, D1, D2, D3. Then our output, which is Y. So let's look at this multiplexer table. As we said earlier, if we are referring to 4-to-1 multiplexer, we are to provide our input lines, which is A and B, then and the output, which is Y. Then under A, we are to have 0, 0, 1, 1. So under B, we are to have 0, 1, 0, 1. Then under Y, which will be the output, we are to have D0, D1, D2, and D3. So this is 4-to-1 multiplexer circuit diagram. So let's see how to create this diagram. Since we said that our input lines are known as A, B, then we have to draw it and put this NOT gate on it. Then we have to include AND gate so that they will be able to help us to analyze those circuits. So our first terminal, which is A, we have to draw the line to the AND gate. Then our second terminal, which represented the B, we have to draw the second line to the terminal of the B. Then the third one, we have to draw it out, which is our input. We have D0. So that is how we have to do it to the second one also. First line should go to A, second line should go to B, the third one should be the one we have to draw outside. Then that's how we did all. Then we now come up to D0, D1, D2, D3. As we said earlier, a multiplexer accepts multiple input and gives out one output. To crown it all, let's take a look of this multiplexer. If the control input is changed to AB, which is equals to 1, 1, as we said earlier, our AB, they are our two input lines, right? So where is 1, 1 located in this diagram? So the 1, 1 is located at the last of those numbers. So all gates are disabled except the bottom AND gate. So in this case, D3 is transmitted to the output and Y is equals to D3. So we are to look at this table. Where is 1, 1 located? Since 1 located is at the last, then which of the number represented it, which is D3? Automatically our output is D3.